Assalamu alaikum all of you. Welcome to one more session for the data representation. Today we will be dealing with the negative values and we will be dealing with what is the formation of the complement. So now what we did in the last sessions, we actually did with the conversions for the positive values, or we were just simply taking them as the numbers over there and we were converting it from one format to another format. Now if we are getting negative value, so first of all we should know that how we're going to recognize that whether it's a negative value or not. So to remember that we are going to recognize by the type of the question, or you may say we'll be recognizing in this format that the examiner will say utilize the complement over here, or it's a two's complement number. The word complement will be there in the question. Now we need to check it out whether it's a positive number or it's a negative number, even though the examiner has utilized the word for the complement. So how are we going to do that? So we are going to say that there are two different types of the sign bits. That is a 0 that is representing a positive number, while the 1 is representing a negative number. Now we need to check out for the first bit from the left hand side. The first bit from the left hand side is always known as a sign bit. Yeah, it may be called as the HSB as well, highest significant bit, and it may be called as the parity bit as well. We will be dealing with the parity bits with the data transmission topic. Okay, now we are going to check this out. So if it's a 1 right now in this example, it's a 1 right over here, that means it's a negative number. If it might be a 0, that means it's a positive number. So if it's a 0, that means you do not need to do anything, or you do not need to perform any sort of the stuff over here. Okay, now it's a 1, that means it's a negative number. Now we need to take out the complement of that. So we are taking the complement just to deal with the negative values. And do remember, we do have two steps for the complement. That is the ones complement, and then it's the second complement. Now what are we going to do with the ones complement? So for the ones complement, we are just going to revert the bits. Now as we know that there are only two form of the bits, the 1 and a 0, because the binary can have only two values, 1 and a 0. So similarly we are going to revert that. So wherever it is a 1, we will convert it to 0. Again 1 to 0, 0 to 1, 0 to 1, 1 to 0, 0 to 1, 0 to 1. Now we won't be checking out for the sign bit. We will leave it right now for the moment. Now for the 2's complement. So for the 2's complement is something that, did I miss something? No, I don't think so. Yeah, right. So now the 2's complement is something that we will be adding a binary one. Do remember that it's a binary addition, and we will be adding a binary one into the 1's complement of the number. So this was the 1's complement. Now we will be adding a 1 into this, and then we will be finally getting the 2's complement. So 0 plus 1 will give you a 1. 0 will be same as it is, 1 will be same. That means remaining bits will be same, and this sign bit will be copied similarly over here. So this is how we have find out the 2's complement of a negative value. Now if we need to check it out, that what was the number, if the examiner says that this is a negative number, now what is the denary representation of this negative number? So how are we going to do this thing? We are going to do this in particular format. The number is 1 0 0 1 0 0 1 1 0 0 1 0 0 and a double 1. So we'll be placing the power of the 2's 1 2 4 8 16 32 64. We won't be counting this bit right at the moment because it is a sign bit. So now if I'm getting the bits that are on, that are considerable, so 16 is considerable right at the moment, 2 is considerable right at the moment, and 1 is considerable right at the moment. So finally we will be getting 19 as an answer. Yeah, but one more thing, that's not the final answer. Why it's not a final answer? Yeah, sorry. So why it's not a final answer? Because we haven't placed a sign over here. This sign bit we haven't considered it, but this sign bit clearly says that it's a negative number. So we are getting a 19, yeah, but a negative 19. Do remember, we are getting a negative 19. Now once we have formatted our 2's complement of this minus 19, now what are we getting as a hex over here? So the answer was something 111 011 111 011 and then a 0 1. So again power of the 2's 1 2 4 8 16 32 64. Okay, now if I'm getting it on, so it will be 64 plus 32 plus 8 plus 4 plus 1. So it will be giving me a 109, I think. So 64 plus 32 gives me a 96. 96 plus 12 will be giving me a 108 and a 109. A 109, yeah, but again, this was a sign bit, so we are getting a negative 109. That means the 2's complement form of minus 19 is minus 109. So this is how we find out the 2's complement. We do have one more and easy method. What is that? That is known as the alternative method. So the original bits were, or the original number was 100 100 We didn't consider this one, but if we are going to consider this one, so it will be a 128. So we haven't considered this one. We are getting minus 19. Now what we actually need to do, we need to subtract the highest bit, that was a negative bit, whatever the value over there is for 2's power. Right, at the moment it was 128. So we are going to subtract 128 from the 19. It will be giving me a 2's complement value directly. So it is known as minus 109 or a 2's complement. It's an easy method. You can go with the alternative method. Coming towards two more things, that's addition of the binary and subtraction of binary. So for the addition of binary, what do we have? Now just consider we are given with two values, that's 1100 and 110100. Let me perform it once again so it could be easy for you guys to understand it. So it's 1100 right at the moment. The other one is I think so the bits are less, 00101 and a 1. Yeah, so the bits were less, so for completing the bits we'll be placing up a 0 over here. Now 1 plus 0 will give me a 1. Do remember it's a binary addition. 0 again, 1 plus 1. Now if we are considering it as a ternary, so 1 plus 1 gives me a 2. What is the binary equivalent of 2? It's a 1 0. So 0 will be at the bottom and 1 will be at the top. 1 at the down now, 1, again 0 at the bottom, 1 at the top, again 0 at the bottom, and 1 will be over here. So these bits, the answer that we are getting is known as the sum bits. The bits that are carried over here are known as the carry bits, and you might see the maximum bits that were given to us were, I think so, 7 over here. 4, yeah, 7, but we are getting the answer on 8 bits. So the last bit will be an overflow bit because it has exceeded the limit. Okay, now might be the examiner is giving you a choice that write your answer in 8 bits, so it won't be a overflow bit right at the moment. Okay, so this was for the binary addition. Coming towards the subtraction, now what is the subtraction or how are we going to perform the subtraction? So again, let me do it for you guys. It's 4 times 1, 0 1, then we do have a 0 1 0 0 1. Okay, so once subtracted by 0, we will be getting a 1 0. Okay, now 0 won't be able to subtract 1 from it, so we will be taking a borrow from here. It will itself become a 0, and now this will become a 1 0. Now 1 0 represents a 2 in the ternary, so 2 minus 1 or 1 0 subtracted 1 will give you a 1 in the answer. 0 subtracted 0 will be a 0, 1 0 and a 0. So this is how subtraction of the binary is done. Now we are done with the addition of the binary, and at the same time we are done with the subtraction of the binary in continuation with the 2's complement format, or why are we dealing with the complement method. So that's all. In the next class, that will be a shorter topic regarding the sampling and the RLE methods. Thank you so much, guys.